Hello and welcome back to Machine Learning. I'm Jivita Christie, and in this video, we are going to talk about continuous distributions. The first continuous distribution that we are going to talk about is uniform distribution. And for a uniform distribution, the probability density function is given by this formula right here. Fx of x is equal to 1 upon b minus a. Where x lies between a and b, and if x does not lie between a and b, then it is 0. And the cumulative distribution function of x is fx of x equal to 0 if x is less than equal to a, x minus a upon b minus a if x lies between a and b, and 1 if x is greater than equal to b. So this is an example of uniform distribution. And mainly this type of a distribution occurs when there is some constant value at which the distribution is held. So if you see here, this is the graph where a is equal to 3 and b is equal to 8. So here is 3 and here is 8. And between that range, the distribution remains constant at a certain specific value. And here the increment given is 0.5. and repetition is 20. So this is what a uniform distribution looks like. Here you can see this is 0.20, and every time there's an increment of 0.5. And at one point it remains at 0.20 till it is within this range of 3 and 8. If you want to calculate the mean and variance of a uniform distribution, uniform random variable, it can be calculated like this. The mean is equal to a plus b divided by 2, and the variance sigma square is equal to b minus a whole square divided by 12. This is a very useful distribution when we do not have any prior knowledge of the actual PDF, and all continuous values in the same range seem to be equally likely. Let's take a look at an example of uniform distribution. So the question says that the amount of time in minutes that a person must wait for a bus is uniformly distributed between 0 and 15 minutes inclusive. Okay, so 0 and 15 inclusive means 0 and 15 both are included in the limit. So that means between this time, the number of minutes that a person has to wait is uniformly distributed, which means it's going to be a constant value. And the question asked is, what is the probability that a person waits fewer than 12.5 minutes? So this is the kind of question that involves the cumulative distribution function of uniform distributions, which is given by this formula. Now the value of our x variable in this case is going to be equal to 12.5. So let me just put that over here. The value of x is going to be 12.5. So x is equal to 12.5. And then the next question that is asked is, what is the probability that the person waits fewer than 12.5 minutes? So if you look at the formula given here, you will notice that the formula has three different states when x is less than equal to a. So let's define first what a and b are. So in our case, the value of a is going to be 0 and the value of b is going to be 15. So these are the values of a and b. Now let's see which of these states actually applies to our question. So this question is x less than equal to a, and that is not the situation for us because x is not less than 0. X is also not greater than equal to b because x is 12.5. So x lies exactly between 0 and 15, which means this is the state that we are in. So this is the formula that we should apply. And to apply this formula, we just have to equate all the values into this, which is x minus a upon b minus a. So we need to calculate the probability of x being less than 12.5. So this is very simple. We just have to put all the values inside, which means 12.5 minus 0, divide that by b minus a, which is 15 minus 0. So you're actually calculating 12.5 upon 15, which will come to about 0.833. So this is the probability, and that is your answer. Let's take a look at another question. On the average, how long must a person wait? So you have to find the average, which is mean, and it is denoted as mu. And you also have to find the standard deviation. So let's take a look at the formula. This is the formula for mean, which is a plus b by 2. And that's fairly simple for us. So to calculate mean, you just have to do a plus b by 2. And we know that a is 0, b is 15, divide that by 2. And that would give you, I believe, 7.5. So that would be your mean. And next, we have to calculate the standard deviation. So we know the formula for variance. So once we calculate variance, to find the standard deviation, we just have to take the root. So let's first calculate variance. And variance is going to be b minus a whole square, which means 15 minus 0 whole square divided by 12. And let's quickly do 15 into 15. So if I do 15 multiplied by 15, that's going to give me 225. So this is 225, and divide that by 12. So 225 divided by 12 is 18.75. So this is 18.75. What I want actually is the standard deviation, which is sigma, which would be root 18.75, and calculating the root of 18.75 gives me something close to 4.3. So this is the answer. Let's take a look at the next distribution, which is the Gaussian distribution or normal distribution. And this is the most widely used distribution in statistics and machine learning. It is known as Gaussian or normal distribution, and its PDF or probability density function is given by this, which is fx of x equal to 1 upon root 2 pi sigma, and then the whole thing is multiplied by e raised to x minus mu square divided by 2 into sigma square. And the corresponding CDF or cumulative distribution function looks something like this. Looks complicated, but it's not. It's actually the repetition of the same formula if you want to remember. This is the value you should remember if you're trying to remember. Only there's this additional limit added because CDF is always about having some range in which you want to calculate the value. And for easier reference, you can also add a function phi z, and you can use phi z and add this whole thing as phi z. And then if you put that inside, you can evaluate fx of x, and you'll get this very simple formula that's very easy to remember, which is fx of x is equal to phi x minus mu upon sigma, and you can derive that phi minus z is equal to 1 minus phi z. And here is the graph of normal distribution with mean value as 4 and standard deviation as 12. So you can see this is a fairly bell-shaped curve, which is having sort of a symmetric kind of shape. So it is, if you draw a line in the middle, you'll notice it's almost similar on left and right sides, and that is what a normal distribution looks like. If you have a normal random variable and you want to calculate its mean and variance, the mean is just Ex, which is mu, and the variance is just sigma square equal to sigma square. Okay. And a standard normal random variable is defined as the one whose mean is 0 and variance is 1. Okay, so the mean is 0 and the variance is 1 for any standard normal random variable. And this is a standard normal random variable with mean 0 and variance 1. This is what it would look like. It would be a perfect graph. Okay. When we talk about Gaussian or normal distributions, it is important to mention the z-score. The z-score is nothing but a score that shows you various properties or characteristics of your normal distribution, and it is calculated in this manner. Um, it is x minus mu upon sigma. So mu stands for the mean, sigma stands for the standard deviation. And what does the z-score specify? It tells you how many standard deviations the value of x is above, that means to the right, or below, that means to the left of the mean mu. So it tells you values of x that are larger than the mean, and they all have positive z-scores. If the value of x is smaller than the mean, it would have a negative z-score. And if x is exactly equal to the mean, then the z-score of x is going to be 0. So z-score is a very important measure in a normal distribution. And we're going to take a look at some numericals or problems where you can apply the z-score. So some doctors believe that a person can lose about 5 pounds on the average in a month by reducing his or her fat intake and by exercising consistently. Now, suppose the weight loss is actually a normal distribution. So in this case, let's assume that X is the amount of weight lost in pounds by a person in a month. Okay, and the standard deviation of 2 pounds is actually X, and it is normally distributed by 5, 2. And we know that when it says 5, 2, that means 5 is the mean and 2 is the standard deviation. Okay, so how do we calculate the z-score? Okay, the question here is, suppose a person lost 10 pounds in a month, then calculate the z-score and tell what it signifies. So this is the standard deviation given to us, 2, and 5 is the mean given to us, and we need to calculate the z-score, and the formula, as you can see, is given right here. So all we need to do here is to put the values in the formula, which means z is equal to, now the question asked is a person lost 10 pounds in a month. So our x is equal to 10. The value of mu is 5, and the value of sigma is going to be 2. So this is going to be 5 divided by 2, which is actually equal to 2.5. So 2.5 is our z-score. And what does that signify? First of all, this z-score is positive. A positive z-score signifies that our value lies on the right side of the mean. So this is value on the right side of the mean, and it is 2.5 standard deviations to the right of the mean value, which is 5. So that's what it signifies. Take a look at the next question, which says, suppose a person gained 3 pounds, which means it's a sort of a negative weight loss, and you need to calculate the z-score. And of course, this is the same formula we will be using. So in this case, we know that x is equal to minus 3. So when we calculate the z-score, it will be minus 3 minus the value of mu, which is actually 5. Divide that by 2 because that is our standard deviation. This would be minus 8 upon 2, which gives us minus 4. And minus 4 is actually negative. So this is a negative value, which specifies that this value, which is minus 3, lies minus 4 times the standard deviation away from the mean. So, and it lies on the left side of them. So this is what we can find out using the z-score of normal distribution. Now, where can you use a Gaussian normal distribution? So a Gaussian or normal distribution is most widely used when you have a study of random phenomena in nature statistics due to a few reasons. The first reason would be it has two parameters that are very easy to interpret and which capture some of the most basic properties of a distribution like mean and variance. The second is the central limit theorem provides the result that sums of independent random variables have an approximately Gaussian distribution, and which makes it a very good choice for modeling residual errors or noise. Also, another reason is that Gaussian distribution makes least number of assumptions subject to the constraint of having a specified mean and variance. So it is a very good default choice in many cases. So if you do not know which distribution it is, you can choose this as a default choice because it has a very specific mean and variance. And it is also very simple mathematical form, very easy to implement, and often it is highly effective. So that's another reason to choose a normal distribution. And the last kind of distribution that we are going to refer in this video is the Laplace distribution. So the Laplace distribution is another distribution with heavy tails. Okay, so unlike the Gaussian or normal distribution, this distribution has very heavy tails. So unlike the Gaussian or normal distribution, this distribution has heavy tails, and it is also known as the double-sided exponential distribution. So it is either skewed left or skewed right. And this is the formula for it, 1 upon 2b e raised to minus x minus mu and mod of that upon b. So this is its probability density function. And here the mu is a location parameter. B raised to 0, b greater than 0 is a scale parameter. And here is a graph of that. So this is what it looks like. It's almost like a probability distribution, but sorry, almost like a Gaussian distribution, but it does not have that bell-shaped end. It has this pointy kind of end, and it puts more probability density at 0 instead of the Gaussian distribution. So this is useful to encourage sparsity in a model. And this figure here, it represents the distribution of Laplace 0, 1 upon root 2. So I hope you understood everything in this video. I'll be back with the next one. So see you there, and thank you for watching.